everyone, myself Priya Shah from Department of Pharmacology at LG Institute of Pharmacy. Welcome to the book series which is initiated by LG Institute of Pharmacy. Do not forget to like, share and subscribe our YouTube channel PharmaIgnite. Now in today's session we are going to study about secondary metabolites. First of all, what do you mean by secondary metabolites? Secondary metabolites means the constituents which can be synthesized from the primary metabolites. Primary metabolites can be synthesized by the normal photosynthesis process in the presence of carbon dioxide and water. In the presence of sunlight, it will form a primary metabolite. Let's begin with our today's session. In our today's session, we will study the other secondary metabolites like tannins, resins, and flavonoids. Tannins are complex organic non-nitrogenous substances. They are polyphenolic in nature, having high molecular weight, widely distributed in plants. Due to the polyphenolic nature, they are astringent in nature. They are widely used in a GI protective purpose. Now, properties of the tannin. First of all, physical properties. They are non-crystalline amorphous compounds, pale yellow to light brown in a color, astringent in a nature, forms a colloidal solution with the water and used in a tanning industry as well as leather industry. In a chemical properties, they form a colloidal solution with the water. They are insoluble with the water, soluble in an organic solvent. They form precipitate or complexes with the chelates like ferric salts, then heavy metals and potassium dichromate solutions. Due to their polyphenolic nature, they are antioxidant compounds. Now let's talk about the importance. Three importance are there: medicinal uses, then pharmacological uses, and last one is the industrial purpose. So medicinal uses, they are mainly used as an antiseptic and antidote for poisoning in a heavy metal, then having astringent activity and antioxidant. Now in a biological activity, they inhibit the plasmins, also decrease the nitrogen content in a urea. And third one is it inhibits the lipid peroxidation. In a industrial uses, it mainly used in a ink manufacturing, then leather industry and preservative purposes. Now let's talk about the classification. So according to the presence of gold-beater skin test, it can be classified into two types. True tannin having the positive gold-beater skin test, while sugar tannin having the negative gold-beater. True tannins again can be classified in three parts: hydrolyzable tannin, condensed tannin and complex tannin. Hydrolyzable tannin again classified in two parts: galley tannins and elaichi tannins. Now here these are the structures of the tannins. Galley tannins, well, two galley tannins will attach with each other, forms a elaichi tannins, and while the COOH group is removed from the gallic acid, it will form a pyruvate. Now let's talk about the important part: differentiate between hydrolyzable tannin and condensed tannin. Hydrolyzable tannins are known as the pyrogalol tannin, while condensed tannins are known as the catechol tannin. Sugar moiety is present in a hydrolyzable tannin, while sugar moiety is absent in a condensed tannin. Then hydrolyzable tannin on a hydrolysis produce gallic acid and elaic acid, while condensed tannin produce catechol and catechu. So hydrolyzable tannins on a distillation gives the pyrogalol, while catechol and catechin are produced on a distillation of the condensed tannin. The example of hydrolyzable tannins are the amla, veda and haldol. The example of condensed tannin are pale catechu, black catechu and terephthalate. Now let's talk about the chemical test. The most important chemical test is a gold-beater skin test. By performing the gold-beater skin test, we can measure either our tannins are true or not. Second thing, it is a qualitative test. In this test, first of all, you need to take a test solution. Then, first of all, you need to isolate the intestine membrane of the ox. You need to wash it with the water. Then give treatment with the acid. And finally, you need to give exposure with the tannin containing extract. So it will react and forms a complex. This complex will react with the ferric salt. So ultimately the final exposure with the ferrous sulfate solution. So if the complex will form, then it will give a color. If the complex will not form, then it must be a pseudo. Second test is the matchstick test. In a stick part, the lignin is there. While you are dipping this stick in an extract, at the time the tannin will react with the HCl and forms a chloroglucinol. And while this stick will give exposed to the HCl, at the time chloroglucinol will react with the concentrated HCl and lignin will give a pink color. So that is known as matchstick test. The Catechu test is similar as a matchstick test. Third test is gelatin test. With the gelatin solution, it will give white precipitate. Fourth one test is a chlorogenic acid test that is specifically positive for the chlorophyll content. So while the chlorogenic acid are exposed with the ammonia, it will form a green precipitate. So that is specifically positive for the pale Catechu because pale Catechu is prepared from the aqueous extract of the leaf. Now, the specific chemical test for the pale Catechu, one is the cambium fluorescent test that shows the green fluorescence. Second test is the vanillin hydrochloric acid test. With this mixture, it will give a pink color. And third one is due to the presence of chlorophyll, chlorogenic acid test is positive. Now these are the FAQs from the tannin part. Now let's begin with the second secondary metabolite, that is resins. Resins are the amorphous, transparent or translucent solid, semi-solid or liquid substances. They having the high molecular weight. They are mainly obtaining from the schizogenous or schizolysogenous ducts or cavities. When they are heated, it will become a soft and ultimately it will melt. Now let's talk about the physical properties. So physical properties, they are heavier than the water. They having high molecular weight, electrically non-conductive and combustible masses. They are insoluble in the water, soluble in organic solvent. Chemical properties is based on an association of the functional group. If it is associated with the volatile oil, then known as the oleoresin. If it is associated with the gum, then known as the gum resin. If it is associated with the volatile oil and gum, then known as the oleogum. Let's talk about the classification of resin. Resin can be classified in three parts: taxonomical classification, chemical classification, and association of the different functional groups. According to that, the resins can be classified. So taxonomical classification is based on a family. For an example, Podophyllum belongs to the Barbaridaceae family. Second is a chemical classification. So different functional groups are attached with the different resins. For an example, if alcohol group is attached, then known as resinol. If acid group is attached with the resins, then known as resinol group. The example of resin acid containing drug is the colophon. Colophony containing abiotic acid. And third one classification is based on a different association of the different group. So that if the resin containing or combined with the volatile oil, then known as the oleoresin. If it is combined with the gum, then known as gum resin. And if it is combined with the volatile oil and gum, then known as the oleogum resin. Now, preparation. So there are two preparation. One is natural preparation and second one is the pathological preparation. Natural preparation is known as a physiological preparation. So while the resins can be secreted out on a natural process, that is known as natural resin. It is also known as preformed physiological resin. For an example, schizogenous ducts or cavities are present in a cloud. Second one is a pathological resin that is also known as an abnormal resin. While the incisions are made on a drug, at the time the resins will be secreted out. That is known as pathological resin. The example of pathological resin is a benzoin and balsams. Now let's talk about the isolation method. First method is based on a solubility. Resins can be extracted with the organic solvent and use precipitation with the water. So first method is extraction with the alcohol and precipitation with the water. Second one method is by distillation method. Third method heating the plant part so it will become soft and ultimately it will melt. And fourth one method that is based on an encrustation that will give the fossil resin. Now identification test. There are three types of identification: physical identification, then examination of powder, and chemical identification parameters like acid value and saponification value. Now let's talk about the flavonoids. So flavonoids are the polyphenolic compounds having 15 number of carbon atoms. Two benzene rings are attached with the three carbon numbers. That is known as carbon chain. So C6, C3, C6. That is the molecular formula of the flavonoids. Flavonoids are known as the plant pigments and they are rich in oxidation. That's why they are known as an antioxidant compounds. They are mainly or widely distributed in the angiospermous family. They are mainly found in fruits as well as flower petals and coloring pigments. Now this is the structure of the flavonoid. A and B are the benzene rings having C6, C6 and A and B rings are attached with the carbon chain. That carbon chain having 3 carbons, that is C3. While this will attach with the oxylinkage, that is known as a flavonoid. So C6, C3, C6. Generally, the B ring is present at the second number of the carbon unit of the C ring. So it is known as a diphenylpropane unit. Right? Now, based or association of the B ring either at a second number of carbon or third number of carbon. On basis of that, the classification of flavonoids can be done. So first is if B ring is attached at the third position of the carbon, then known as the isoflavones. If it is associated at the fourth number of carbon, then known as neoflavonoids. If the ring chain is open, then known as dicones. If the B ring is present at the second number of carbon, but the association of the different functional group, on basis of that, they can be defined as the flavones, flavanols, catechins and others. Now let's talk about the sources. Flavanols can be obtained from the fruits like apple, strawberries. Isoflavonoids can be obtained from the grains. Flavanols can be obtained from the different like orange peel, lemon peel and grapes. Role of the flavonoids in a plant, it induces the root nodulation. It is very helpful in a nitrogen fixing bacteria, rhizobium. So second is the role of the flavonoids in a plant defense, and third one is due to the polyphenolic nature they are antioxidant. Now let's talk about the chemical test. Shinoda test is an important chemical test for the identification of flavonoids. In a Shinoda test, take a drug extract. In an extract, add HCl and then lastly you need to add a magnesium ribbon. So it will give a pink color. For the comparison of the pink color, you need to take a control sample. In a control sample, take alcohol. In that, you need to add HCl and magnesium ribbon. So by comparing the value, you can say the Shinoda test is positive or not. Second test is lead acetate test. With the lead acetate solution, it will give a yellow color precipitates. Now benefits, it reduces the risk of cardiovascular disease. It is also useful as an antioxidant, reduce the blood pressure, free radical oxygen scavenging activity, then anti-inflammatory activity, then antiviral, antibacterial activity. It inhibits the large density lipoproteins. It increases the high density lipoproteins. That's why beneficial in a cardiac disease. So these are the FAQs from this part. Thank you for watching my presentation.